Any second now.
Okay. Okay, we're here. It's a once a week online live vlog and podcast, if you will. The Santa Barbara, California's longtime telescope and astronomy club, the Santa Barbara Astronomical Unit. Heard and seen every Monday morning at 11 a.m. for an hour, over 3 years now. We call it the SBAU Astro Hour, and I'm your proud host, Ron Herron, Vice President of the club, and I'll proudly introduce you to the rest of the board in a minute here, some very passionate members. Meantime, follow along with us on YouTube. Be ready to comment or ask questions, everybody, because I got to tell you, I'm proud to be working with some of the brightest, most knowledgeable minds and folks in town. Come join our club. We meet up at the beautiful Santa Barbara Museum of Natural History in Mission Canyon every first Friday of the month, 7 p.m., usually with the planetarium show. It'll be reversed this coming month of April to the following second Friday of the month, which will be the April 12th. And in doing that, we'll also move up our second Saturday of the month Star Party. Usually that would have been on the 13th, and we're going to move it up to the 6th.
Ron, just a quick note. The planetarium is closing next Sunday after the last show Sunday and won't be open again until September. So there won't be planetarium shows.
So one note I didn't have. So there won't be a free planetarium show. However, we are going to go to the 8th of April in the morning. That's one of our program days here, which may not happen as far as the Astro Hour, but this is what we're looking at. Let me introduce all the guys while we look at what our sun's going to look like on April 8th, that solar eclipse. President Jerry Wilson, a small picture on the screen, but wave at us, beloved president, 6-7 years. He's married to Pat Forgy and happens to be the godfather, believe it or not, of the man from JPL who powered and piloted the Ingenuity helicopter on Mars. That may or may not turn into anything. Chuck McPartland, finally going solar, is our longtime beloved outreach coordinator, best in the whole country as far as we're concerned. He's married to Pat McPartland, who is merchandise manager, as well as our new treasurer. We have Bruce Murdoch joining us, longtime supporter and telescope enthusiast. Guess he's going to go up on Camino Cielo. He'll tell about us watching the solar.
Bruce, you need to stop sharing.
Too much?
Yeah.
What does that mean, sharing?
Because it takes over the screen.
Yeah.
Oh, okay. Yeah, let's see up everybody's nostrils here. Bruce is married to Bonnie, longtime supporter, telescope enthusiast, president of the Santa Barbara Theater Organ Society. We have Tom Whittemore, former Westmont College instructor, waving at us. He is monthly newsletter editor, and he's married to Maureen. And Tim Crawford is joining us these days, resident lens and telescope expert, who is married to Karen, has to do with our workshop on Tuesdays, and probably plans to be out at Camino Real on that morning. Hopefully it'll be a sunny day till about this time. I guess it'll be over or beginning, or we're not going to probably have meet on this program on the 8th, are we, gentlemen?
No,
probably not. The eclipse starts a little after 10 and ends a little before 12:30.
Has anybody thought that we could take if they have Wi-Fi out there, take a laptop and do the show from there?
Yeah,
it takes too much concentration to do the show, and there'll be too much other activity.
Yeah, and the bandwidth might not be very good out there.
Yeah.
And somebody would have to be back in your main headquarters there, Jerry, right, to run the program.
No,
right?
No, I could run it from out there.
Oh,
it's too distracting. I think we're just going to make a clean ghost session.
Well, this just happens to be the 162nd program, and I've got that marked down as 164, but I'm going to have to make that the following week, which would have been 165. For the week of March 25th through the 31st, we are on board, and we're going to talk about the full moon, which may or may not have happened. It's about full moon time now, 2 weeks.
Last night.
Last night. And I guess the moon is we're in Lupus, NGC 5822. We're going to go out and check those up in the night sky.
Nice.
Yeah, and a penumbral, a lunar eclipse occurred overnight. We had another eclipse.
Yeah.
We'll talk about that. Asteroid 4 Vesta may or may not be a planet, but doggone, it's in Gemini. Jupiter and its Galilean moons, where they are, and an in-depth look. I mean, in-depth. We're going down deep into the great red spot on Jupiter. Devil's Comet coming in close to the sun. Good old 12P, Pons Brooks. And a Scotsman discovered Proxima Centauri back in 1915. It's now a 3-star system, our closest neighbors out there.
I remember.
Hey, what'd you say, Tim? I
remember him well.
You guys went to school together. Okay, am I sounding all right? I was breaking up earlier.
Yeah, you're sounding good.
All right, and here we go to the silly science cartoons that Jerry likes to email us. This is the Lunar Rushmore, and I like to think this was Stanley Kubrick's first choice to be buried on the moon, but not there for 2001: Space Odyssey before he picked the monolith. There they are. Presidents of an alien world. Okay, this one two things that drew me to astrophotography were the expense and the inconvenience. Certainly a reason. You agree? Is it climbing or not?
It's self-punishment.
Okay, guys,
this is really true.
Get what you deserve. UFO caught on tape, or a UAP scotch taped, if you will. That's unidentified aerial phenomenon. A little play on words. And here is the definition of entropy, ladies and gentlemen. I dusted once. It came back. I'm not falling for that again. Tendency of things to break down. And this one I call levitating liners, but you call it flying cruisers.
Well, this showed up on the astronomy cartoon website. It's just an interesting optical illusion.
Sure, that's a real picture.
Yeah.
Somehow the atmosphere eliminates part of the horizon or part of the ocean.
You're actually looking over the horizon. The temperature differential, the atmosphere is layered in temperature, and it's acting like a big lens and bringing light from over the edge.
You're kidding. We're seeing boats that are actually out of sight and below the horizon?
Yes. And the other thing, you can see this if you're driving down 101 frequently and you look out at the island of Anacapa, which normally has cliffs all around it. But at a lot of times, the temperature variation is such that it makes the cliffs look super tall.
Yeah, and the boats and the big freight ships that go by.
This isn't always, it's a rare occasion. You see this, right? It's illusion.
It's special atmospheric conditions. It's the type that might give you the green flash if there were sunset taking place.
You took the words out of my mouth.
Alex Filipinko had an astronomy course on a bunch of CDs, and in one of the early CDs, he had a freighter going by. I think it was the atmospherics caused it to look like there were two ships, one upside down, one right side up. I can't remember exactly, but it was quite a picture.
Okay, here it is, $100. The big rock boulder sitting on top of Wile E. Coyote.
No bet.
There's a coyote under here. I got $100. All right. Back to the Lunar Rushmore. USA climbs down. Thank you, Mr. President. Always good to start with a little levity. Now let's get serious and go into the night sky. We're going to look for the bright stuff this week, right?
Yeah.
Overnight we had the full moon. What's this one called?
The worm moon.
A worm moon.
Worm moon, or I think a snow moon, oddly enough.
Well, not oddly enough.
Astronomy magazine gave it the worm moon.
Okay, well, it's spring. Spring has sprung, and this is a globular cluster, isn't it?
Now this is the wrong order. Let's see if
this is an open cluster, Ron.
Yeah.
Yeah, this is. I got two of them mixed up here. The three of them mixed up. Anyway, never mind. Just rambling. This is a finder chart for because the full moon was yesterday. It's pretty bright up there. So the idea is that we look at star clusters. And to make it challenging, this star cluster was way to the south. You can see on this finder chart, you can see the very low tail of Scorpius here. So this is a decade of degrees below that. So if you're here at 34 degrees north latitude in Santa Barbara. You can just see this if you have a clear horizon and you're up on the mountaintop. This is in the constellation of Lupus, and it's in the bottom, the most southerly part of Lupus. It's a prominent open cluster, NGC 5822. It's not in the Messier catalog because there's no hope of seeing that from Paris. So Messier never had a chance at it.
Really?
Can you get that one, Tom?
Yeah. I've never seen it. I mean, if that's before the sun comes up.
Okay.
Isn't lupus a disease?
This is the
This is the
open cluster, NGC
Open cluster. Okay.
5822.
Mhm.
It's quite bright.
Hmm.
But I think it's only like 2 degrees above our southern horizon.
Okay. You know the declination, Chuck?
It's minus 54 degrees.
Ooh, that's on the edge of visibility.
Yeah, it's right down there for us.
Yeah, we can technically see to minus 56, technically.
Mhm.
Well, that's not magnitude you're talking about, is it?
No.
Location.
Oh, location. Okay.
So that is a real challenge.
Uh-huh.
So on a much easier note, a much easier target, and a very dramatic target is M3 in Canis Venatici. Right there, there's the constellation Canis Venatici. This is the outline of the constellation, the official property line.
You see the star hop I used there, Jerry? Between
What's that?
The star hop I used between Corcaroli and Arcturus.
Yeah, that's what I used to use too, Tim. Yeah, it's not quite 50% of the distance between the two.
No, it's not quite. Little
So you're
closer to
pointing
the
out these two stars, Corcaroli and Arcturus.
That's right.
And so this is about a little bias toward Arcturus.
Yes.
Yes.
Now,
Now
it's
the way,
like 60-40, like 60-40.
yeah.
Yeah.
Now it's got a nice star hop to verify that Arcturus, you'll have no trouble seeing Arcturus. But whether it's Arcturus or not, you need to go up here to the Big Dipper, which is very prominent. Everybody can find that, and follow the arc of the handle down here. And it ends up on Arcturus. You guys taught me that.
Does the word canis involve dogs?
Yes.
Yes.
It's dog in Latin.
That's what I thought. Okay.
That's the plural. It means hunting dogs.
Okay. And Venatici had something to do with Italy, I'm sure.
Hunting. Venator is a hunter.
Okay.
Yeah, Ron.
Go ahead, Chuck. Get
Greeks.
him with that really nice the thing you always say about the hunter and the backwards words. It's pretty
Who,
cute.
me?
Ron, I'm sorry, Chuck.
Chuck.
Well, what I was going to say was, according to the Greeks, Boetes there, that's on the left, is a herdsman, and he has some hunting dogs, which is the Canis Venatici, and the dogs are chasing the bear, and that's what keeps the sky rotating.
The word Boetes to me means a large void. There's a big hole out there in space around there in there.
It's a herdsman.
Okay, well, that's not Italian, I don't think. Unless
No.
Boetes use little dots over the O.
Yeah. And the way this thing comes up, Ron, over the horizon, and Arcturus is up before 9 now, like 8:45, is what you see is a little hockey stick coming up kind of on its side, consisting of Izar, Arcturus, and Mufrid. That's what I see coming up over the eastern horizon.
There's Izar.
Arcturus and Mufrid. So it looks like a little hockey stick. See?
Oh, I see. Okay.
That's how it comes up. That's how I see it. Okay. See, Genus comes up too, but I don't think it's nearly as bright as these guys.
Well, have you guys ever seen a list or made a list of the things that you can normally see with a new moon that you can't see with a full moon that just disappear?
Yeah. I think
pretty much any interesting faint fuzzy goes away.
Right.
If you want
Depends where you are too.
If you want to make that list, Ron, it would probably be better to list the things you can see.
Well, that's what we're doing right now. I was just thinking about what's not.
Oh, hey, Jerry, would you mind going back to that one? Just a little tidbit here, if you wouldn't mind. That Corcoroli is actually a double star. It's a really interesting one. And it turns out the main star is about 110 light years away. So when you're giving a public outreach, you can tell the folks that the light you're seeing came from the time when Archduke Ferdinand was shot.
No kidding.
This brings back, I can recall we've been to star parties. This goes back, like a decade before LED streetlights. And you could look up, you could find Arcturus and you could see Bootes easily.
Yeah.
You can't anymore.
Really?
Can't hear.
Well, okay. Well, I guess I live in the wrong place.
Yeah, it depends.
A different place. A different place.
Well, I don't
suppose. Okay. So this is M3.
M3.
That's
M3. It's a very densely populated globular cluster, probably close to as old as the universe is.
Mm-hmm.
Really?
Oh, really? Wow.
Older than our galaxy, then?
That's a belief that because these clusters contain very old stars, and they're not giant stars, so they didn't burn through their helium or hydrogen right away.
So galaxies didn't create stars; scattered stars coalesced and formed galaxies. Is that what?
That's a complicated scenario.
Wow.
Gravity sucks.
Galaxies can be very, very productive of stars. It depends on what goes on. They have a lot of gas in them, and the gas gets disrupted by exploding supernovas or collisions with other galaxies, and it makes gas run into each other and form highly dense things that then collapse into star-producing regions. When the universe was very young, it was very dense. The whole thing was, everything was closer together. So there were more big stars then, and the stars were mostly pure hydrogen, and they were giant stars in general. And so they burned through their hydrogen very quickly. That generation of stars is gone, and it produced a lot of elements, heavier elements than helium and hydrogen right away, and gave up rise to the metal-rich stars that came later.
Well, Neil deGrasse Tyson's latest email or latest video on YouTube says that the Webb just discovered 10 more really distant early galaxies. Muddle everything's Big Bang Theory, I guess, again.
Ron, that's already old news, and they've found that some of those things weren't what they thought they were. There's no threat to any kind of Big Bang cosmology. That stuff is just speculation.
Mm-hmm. Yes, and as they go over the data and use other methods of reducing the data to information, they're finding that these initial fears are not justified. The major unknown in astrophysics right now is the different Hubble constants that you get depending on how you measure the Hubble constant. And the accuracy of each of the two measurements is increasing. It's becoming much more precise, but the disagreement between them is becoming much more established and possibly very real. So that's the real conundrum going on.
Maybe it's not a linear number. Maybe you have to take a second order, approximation.
All sorts of speculations are being put out there.
I got a trivia question for Tim.
Uh-oh.
That's right. What was Edwin Hubble's favorite chewing gum?
Oh, no.
Hubble Bubble.
Thank you. Good job. Hubble Bubble.
Hubble Bubble. Give me a break. Next week is going to be a killer for good old Tom Whittemore, because it's April Fool's Day.
Yeah, but the next day I'm giving a talk to Gen students. It's going to be nice. On mirror making.
Well,
wow.
Should have Tim Crawford do that.
Why?
No. Tom's the man.
I taught him.
Yeah.
He taught me.
Tom is who we go to. So
what's that?
This is a photograph of a full
moon
with a penumbral eclipse going on. And
really?
you can see it's not very noticeable. This side of the moon over here is slightly more tan in color, in tone, than this side of the moon. That's because this is the outer shadow. Remember, there's two parts to the shadow of the Earth. Because the sun is an extended object, it's not a point object. It produces a long cone of light, and then inside it produces a denser cone of shadow, a long cone of light shadow, and then inside a denser cone of shadow. And only the outer cone of light shadow is intersecting the moon here. So it's just shading it lightly. No red color, no moon. It's not obvious. People looking at it, if they didn't know it was an eclipse, probably wouldn't know it.
Did anybody watch it last night? Chuck, anybody?
No, we went out and looked to try to catch Pons Brooks low on the horizon early.
Yeah.
And, it was raining and windy and cloudy.
And tell me about it.
We kind of said, we're not going to stick around too long.
Yeah, Maureen and I tried to get it last night from the front yard, because we got a line shot to that area. We couldn't even see Mercury.
Yeah. We did see Mercury.
Did you? Yeah.
And the arch of that moon bow that we saw went right through Jupiter too. That was cool.
It's pretty neat. Yeah, I got a beautiful shot of a rainbow on the flip side of the sky. Well, obviously where the sun was still up. It was really pretty.
Well, gentlemen, as far as this penumbral is concerned, if we had Apollo astronauts on the moon right now, would they be looking at the Earth in the distance, just touching the sun?
Kind of taking a bite out of the sun. If they were in the part of the moon where it's shaded.
Partial eclipse.
Yeah.
But we've never seen an Earth eclipse from the moon yet, have we? Be a rare.
No, I haven't.
Well, I know you haven't, but I'm just curious if it would obliterate all of the sun, or would there be a ring around it? I wonder.
Oh no, the Earth is much, much, much bigger in proportion, so it would definitely cover the sun.
Oh, it would. Okay. Still, that's 250,000 miles away.
Okay, so the next eclipse coming up, of course, is the solar eclipse. But the asteroid Vesta is in this region of the sky, near Propus, in the border between Taurus and Orion and
Gemini.
Thank you. And it's in the region of it's just passing NGC 2129 right now, and it's heading for M35 and NGC 2158. We've covered these in detail on a previous occasion, and they're very nice clusters. They're open clusters, which is our theme for tonight, because they're easier to see with all this. This is 2129 taken through a reflector.
Would we see that reddish cast if we got these? Even a hint of it?
You would probably see a hint of it with the starlight. You can tell, for example, looking at Antares, that it's red, and Betelgeuse that it's red.
Yeah.
So
the question for this one, since it's so many of them are red, even in the background, is this dust coming between us and reddening it, or is it actually a low temperature star?
Right. So the dust effect you probably would not see so much.
When you look at Herschel's garnet, it's quite red.
Yeah. Some people can see color in stars, some can't. My wife has a lot of trouble seeing that. I put Antares in a 12-inch scope one time and had her look at it, and she said, well, she kind of thinks there might be some warm tones in it. So for some people, stars just look white.
Yeah, I've noticed that at star parties, Jerry. Some people don't see it at all.
Yeah.
But they don't ever look green. That's only comets, isn't it?
Well, no, there's several that do look green, but it's an optical illusion. There are no green stars.
Is this still your four Vesta story? You headlined it, "No Hope of Being a Planet Again," and I never got an explanation for that.
Oh, it's a small asteroid. It's not big. It's not as big as Ceres, for example. But it was once considered a planet.
A dwarf planet.
A what?
A dwarf planet.
No, it was once considered a planet.
Oh, a full.
Wow.
In the 1830s or so, there were 18 planets in our solar system. Okay. Because Pallas, Juno, Vesta, Ceres, they were all considered planets until photography came along and they said, oh, we're finding thousands of these things. They're like rats. We're going to call them minor planets or asteroids.
And also back then, to allude to a Cummings story in this, they knew our closest stellar neighbor was one big star called Alpha Centauri back then, wasn't it?
Yeah.
Oh, they knew it was a double.
Yeah.
They thought it was a double. It's now a triple. Okay, we'll get to that in a few minutes.
So this is showing the region. If you're looking at Vesta, which I didn't show pictures of because it's just a dot, but it's passing through a very interesting region. And these are the other two open clusters in that region. This is M35 up in this region. That's a big open cluster. And this is NGC 2158, a much tighter open cluster.
Which is about 5 to 6 times further away than 35.
Yeah. Why it didn't get an M number, I don't know.
Oh, it's much dimmer than M35.
Oh, it's way dim, Jerry.
Yeah.
Well, that must be why.
Probably can't see it now.
And Westmont's 8-inch, if it's a good night, I show it to folks.
It's great. Yeah. From the gun club, somebody lent me a Nagler 13 Type 6, and I got this view in my 10-inch. And when I saw 2158, I went home and ordered the eyepiece.
Yeah. What a sucker.
I know. It was great.
Did you get the one that had 2158 already in it?
Yeah, right. Yeah, painted on the front.
So this has got a nice little asterism in it.
Really?
See this little line of stars right across it, like a multi-eyed alien.
That's an asterism. 3 stars in a row.
4
in a row. It's like a mini 100.
You don't usually see that.
Yeah. 2158's belt.
The belt, yeah.
All right.
Here we go.
Here we go.
Now we're getting to Jupiter. This is a planetarium program. This is the 25th of March today. This will be tonight about 8 o'clock, 10 minutes after 8. And the reason I picked that time is because you can see the great red spot is about center on the disk. And again, then 10 hours later, it'll be on the disk again as it rotates. The planet rotates about every 10 hours. So you can look up on charts. This one I did for March 28th, which is Thursday, I think. And you can see the great red spot will be centered at these times. So on the 27th, it'll be at, this is local time. This is universal time. Okay. So this is 3:27, which is Wednesday at 10:30 p.m. This is 8:30 p.m. and 6:25 p.m. Now it is possible to see Jupiter in the daytime and even find it because it's quite bright. And if you know the rough region about there and you have a fairly good telescope, you can look there and pick it out in the daytime. And I don't know if you can see the red spot during the daytime, but you'll see the planet.
And Chuck does that fairly often at star parties.
With a 10-hour spinning day, you can see the red spot somewhere once a day, I'm sure.
Well,
maybe not at night.
Yeah, that's pretty much true. Yeah. As long as it's up at night. So these are screen captures from a video. So that's why all this extraneous stuff is down at the bottom. But this portrait shows weather phenomena on the planet. This is, let's see if I can make that bigger. This is called a brown barge. This stuff. These are hot spots. These belts all have names too. I should have put a chart up of that in there because these are steady features. You look a year ago or a year later, and you will see pretty much the same belt structure. There's not a big set of difference. This is, of course, the Great Red Spot here, and this is the Red Spot Junior.
Is north up in this?
I don't know which way it's up in there. I should have noted that.
That's okay.
I assume it is. When the pictures I see of the Great Red Spot, the red spot is always below the equator. So I think this is the south down here.
I think it is in the southern equatorial belt.
Yeah. This is a superstorm going along here. There's a lot of detail, and some amateur imagers can get this stuff, can get pictures taken like this, processed with fairly large scopes.
Well, if the Great Red Spot were in the northern hemisphere of Jupiter, would it be turning the other direction?
We'll get to that. There's not a lot known about it. It's been studied for 150 years. It's been noticed for 150 years. When I started in astronomy in the late 50s, this was really orange. It was really prominent. It's and about 10 or 20 years ago, it was quite faded. And it's a brighter color nowadays, more like this, but it's not as bright as it used to be into my memory, or maybe my memory is eulogized a long time ago.
But on Earth, these big storms that rage in the southern hemisphere around like Australia go in the opposite direction of our northern hemisphere hurricanes, don't they? The Coriolis effect?
I'm sure there is a Coriolis effect on Jupiter. I don't know. The myth about toilets flowing the other way in the south is a myth.
Oh, it is?
They flow any way that the toilet is designed to flow. But this is a kind of a storm that's called an anticyclonic. Now, what we get on Earth is a cyclonic storm, and we very rarely get an anticyclonic storm. So the cyclonic and anticyclonic deals with how this rotates compared with how this stuff is passing it.
Huh.
So we'll get to that.
Okay,
but we're going close up. This is a Hubble picture, close up of the, I think it's a Hubble.
Wow.
Let's see.
That Juno probe comes around in every, 55 days?
It doesn't say where the instrument is, but it gives the person that took the picture, Mark Garlick. So, but it is a very clear, very highly magnified picture. I suspect it's Hubble. Hubble information is available. Raw information is available. And there's a program that you can go to and you can download, because there's a standard format for images in astronomy called FITS, F-I-T-S. Mm-hmm. And you have to be able to read it, and that because it has a large header in it that has a lot of information in it. So that's why it's used. There's a free program called a FITS Liberator, which lets you download programs that are stored on the web, on the internet, in FITS format. And NASA puts all their stuff up in FITS format. So you can get the raw image and then you can process it yourself. It's a little tricky because all the pictures are taken with things that are taken by satellites and by major observatories are not after pretty pictures, they're after scientific data. And so the filters they use do not readily correspond with what we use in our hobby of red, green, and blue. They have extra detailed sets. You can construct red, green, and blue using some wizardry out of that, but it doesn't readily come that way. So it's a bit of a challenge to process these images. But several amateurs have managed that, and you can look up their stuff on website about processing Hubble images, for example. But this shows
Juno images are also downloaded. They're available as soon as they're downloaded.
Right.
They have, tips and hints on processing them. So a lot of amateurs grab those images and process them.
Yeah, and I suspect that's what happened here. This is definitely what happened here. This is an amateur processed picture. taken from the Juno, from the Juno cam imagers on NASA's Juno spacecraft.
Wow.
Citizen scientist Jason Major using data from the Juno cam. And this is his process. So it shows the, yeah, it's not obvious to me which way it's flowing there. But this looks like it's flowing this way, and this looks like it's flowing this way to me.
Well, there are videos that show it, aren't there?
Yes, there are very dramatic videos that show the band flowing around it and the thing flowing in an anti-circular pattern.
Here we are in depth.
Now,
I just got an interesting from Sky Safari that there's an Io shadow transit just started on Jupiter.
Yeah, okay, good. I'll rush outside.
I know.
So this is a bunch of Juno data. It's from the microwave radiometer, and these layers here on down are microwave data.
Yeah, this is great, Gary. This is so neat.
Top layer is visible light. This is north. This is a Juno cam image, and this is the depth below the cloud tops. So this is the channel that was used, but this is in kilometers. It goes down in, this is 0 kilometers. So this is the cloud top here. And this is 20 kilometers, 50 kilometers, 90 kilometers, 150 kilometers, and 350 kilometers. So it's not exactly linear. And it displays, because it's a okay, it's thermal images. So this is, the darker colors are intuitively cooler. The warmer colors go to white for the hottest.
Close
it's
to
not
infrared.
Calibrated, but
Okay.
What's that?
Close to infrared, right? Color red?
Yeah.
Okay.
Well, it's microwave. This is beyond infrared.
Oh.
But,
yeah, the color here has nothing to do with infrared.
Yeah.
Oh, okay.
So it shows a great deal of depth to this thing. So the structure, the storm structure, goes down 350 kilometers into the atmosphere. Now, our atmosphere, being very generous about it, it's only 60 miles high. What is that, about 100 kilometers? So, and by that time, it's really, that's the Kármán border with space that defines where space starts.
Really thin.
So this is a much deeper structure, and it's stable. Apparently, why it's stable, nobody knows.
About 280 miles or so deep.
And this is a set of 3 images taken. This is infrared, and here white light is hot, and dark is cooler, not cold. It's all warm. Jupiter actually puts out more radiant heating than it gets from the sun, so it generates heat, and it generates heat from gravitational collapse, not from fusion.
Not from magnetism.
What's that?
Not from its magnetic field?
No, magnetic field is not an efficient generator of heat at these levels.
Really?
Yeah.
Okay.
So the thing of note with Jupiter's gravitational field is that it traps radiation, and it's the radiation that is damaging and kills electronics and would kill astronauts if they traveled in it like Juno is. But it's not terribly hot. This is a visible image, which we're all familiar with. And the next image down shows the visible and an ultraviolet image.
You know what we don't see much of is those colorful poles that look like tie-dye shirts.
I think this is is it Saturn or this one that has a hexagon at the pole?
That's Saturn.
Saturn, okay. So this is the infrared and the visible were taken with the Gemini North telescope in Hawaii, and the ultraviolet was taken with the Hubble Space Telescope. So let's see. 3 views of Jupiter. No, where's that?
What is that storm is turning at what, 400 miles an hour, something like that, Chuck?
The winds in that neighborhood are hundreds of miles an hour in the belts.
Unbelievable. Dude, what hell of a day for sailing.
What I just learned about those super distant galaxies being picked up by the Webb is that they started emanating ultraviolet, and by the time it gets here, it's slipped clear through the color spectrum down to infrared, hasn't it?
Yes, they've been beyond infrared.
But the Hubble could have seen them if it was still ultraviolet, but it can't because it's infrared now. Wow.
Let's see here.
One of you sent out a picture of what was it, a moon bow?
It was a moon bow last
that
night.
Was Chuck sent a picture of a moon bow.
And during my walk yesterday, I saw an arc of a rainbow, the brightest I've ever seen, going right down into the Riviera, about 45 degrees of it.
Mm-hmm.
That was coming back, and you saw something on the moon that's similar. Is that?
Oh, it was moonlight making a rainbow, basically. Yeah.
Yeah.
Oh, that's what it means.
As that one joke I saw showed, a man is talking to a vampire, and they're looking at the full moon, and the guy says, the full moon is nothing but reflected sunlight, and the vampire immediately turns to dust.
And we were speculating that if we followed the moon bow, they might be a pot of silver at the end.
Silver. Good. Faith in Bagora. Okay.
Here we go.
What is known about the Great Red Spot? This was an article by Scientific American, and I clipped this out.
Oh boy.
So research, there's 5 points here, and they all sum up to basically, they don't know, or we don't know. Why does it appear red? Some researchers think it could be due to chemicals like ammonia in the upper part of the storm. The spot seems to be changing color over time. I can attest to that personally, which all researchers also don't understand. In 2014, it had been taking on the ruddy orange color that is slowly intensifying, according to NASA. The change could be due to changes in the storm chemical composition or the distribution of gases within and above it. So though Jupiter is very different from Earth, the dynamics governing storms are similar. Therefore, a better understanding of Jupiter's storms, including the Great Red. So this is just political platitude here. So the Great Red Spot has a smaller counterpart called the Little Red Spot. We saw that. The gases
actually, at one point, there were 3. There was the Great Red Spot, the Red Spot Junior, and the not so great Red Spot.
Yeah.
and the Great Red Spot swallowed up the not so great Red Spot.
Oh.
So the gases above the Great Red Spot are hotter than anywhere else on Jupiter, according to a 2016 study.
Now that doesn't seem to match the infrared image that we saw earlier.
Yeah, exactly.
What did you just say, Mr. President? The red spot is the hottest spot on Jupiter?
Yeah.
Wow.
Well, yeah, it shows dark here.
Oh, okay, got it.
Well, I thought in that image the dark was cooler.
I'm assuming that, but you can, it's a simple flip of a switch, because when you look at an infrared camera, it is all arbitrary. It's all false color.
Okay.
And
we're looking at
flip it so that it's white hot or white dark or white cool, either way.
It's interesting that the Great Red Spot is seen and not Junior in this image too. You can't really spot it.
This is Junior, and I think, isn't this Junior?
No, it's not. It's right to it's right there. It would be right there, and you can't really see it.
So the picture on the left is a color negative?
It can be. They don't say which it is. Usually when we take images with infrared cameras, we put down there white hot or white cool, so you can tell which way it is, because they'll be displayed either way. So
it's interesting that your point was it was really hot above that red spot. That I didn't know.
But would it be safe to say that since every one of those belts has a different color, are we dealing with different gases on Jupiter?
I've always wondered that.
The bright spots are clouds of ammonia ice crystals. The darker bands are sulfuric acid and methane.
What I don't get is why they don't, I guess they're not miscible, why they don't blend into a solid mass or call it whatever.
And I think some of them are different altitudes also.
I thought there were kind of like thermal currents ducking down in and then coming back to the surface. That's what I thought it was between the belts and the zones.
I've seen some depictions of different speeds for every belt. Some are going faster than others.
There is a lot of motion within the belt. You can see in videos that are put together of the planet where you can resolve it. It's typical storm activity, things rotating around and blowing by each other, tremendous windstorms. But it's like the jet stream on the Earth. They seem to be steady. The jet stream on the Earth changes quite a bit and gives us a lot of weather south of the pole. So they think that this, it says the gases above the Great Red Spot are hotter than anywhere else on Jupiter. Researchers think the reason for the heating is acoustic waves created by the extreme turbulence in the storm.
Just out of curiosity, gentlemen, our late British friend, the balloon expert Julian Knott, wasn't NASA working with him to make balloons to go either to Venus or to Jupiter, right?
They still are.
It was to go to the moon of Saturn, to Titan, because it has a thick atmosphere.
Oh, okay. There's no plans to think about putting a damn balloon into Jupiter's atmosphere.
No, it's a little too violent, but they are thinking about doing it for Venus.
Miss Julian Knott. I had him as a guest twice. I think he was in our club, wasn't he?
Yeah.
Yeah, he's a pretty cool guy.
He's really nice guy. Really
expert. Nice. Okay, where are we now, Mr. Prez?
We're back to the end of Jupiter.
Aha.
So, that can magnify. Okay. Just learned a new feature here. Okay, this is a star Hamel. Why are we looking at Hamel? That's because it's 1.5 degrees northeast of the comet Pons Brooks. Now this, of course, you'll immediately identify the stick figure as a ram. So,
and that little sort of hurricane symbol down there, the red one in the lower right, is about where the comet was supposed to be last night when we were trying to catch it.
Okay.
It was along a line from Jupiter through Hamel and then down a little into the left, and that looks just about right.
Okay.
Why do they call it the Devil's Comet?
Oh, just because it had some kind of eruption and it looked like it had 2 horns coming out of it for a while.
Oh, got it.
2 tails.
But was this done by the ancients? Has it been around that long?
No, this is recent, just media stuff.
Oh.
We have primitive people among our population today. We don't need to go back in history.
I think I'm looking at 6 of them right now on the screen.
So there is Jupiter down here, and here's the galaxy that Chuck was mentioning. Hamel is forming almost an equilateral triangle with it. And it's about 1.5 degrees tonight from Hamel. So this, and people are gearing up now. It's showing a distinct green color, long, thin tail. And people are gearing up now to try and see it during the eclipse on 2 weeks from today.
And last reported it was visual magnitude 5. So that's pretty visible.
Yeah.
So binocular.
Whether it's visible, you don't get darkest skies during an eclipse. But this one will have the longest darkness of, I think, ever in recorded history for the U.S.
Really?
It's something like, well, I don't remember the number now. The one I saw down in Queensland was a 4.5 minute totality.
I think this one's a little over 4 minutes, but
yeah.
Is there a predicted one for the future that comes across us, Paul?
Not in our lifetime.
Not in our lifetime. All right.
On average, on any one given spot on the surface of the Earth, you can expect a total solar eclipse about once every 370 years.
Well, I still totally don't understand why it goes at an angle, why it just wouldn't go across the equator, on a flat. That sounds like
What do you mean go across the equator? You mean the comet?
Well, no, the path of the solar eclipse. Why wouldn't it just go on the ecliptic? Isn't everything?
Because Ron, the moon's orbit is tilted 5 degrees relative to that. So it depends whether the moon is at an ascending mode, a descending mode, the direction it's traveling when it passes in front of the sun.
Well, that seems to be more than 5 degrees compared to the equator. It's going northeast down to southwest.
Yeah, and so they're always going generally west to east because that's the motion of the moon.
Okay, is it going up, not down the Earth?
Right, it's starting in Mexico at Mazatlan.
Oh, I thought it was okay. They don't put the direction on it. I got you. All right.
So this photographer, Manolo Gomez, has captured the green color around the head of Comet over the weekend and posted this picture on Flickr with a long, thin tail. So we'll see how that goes on the 8th. Now this,
a Scotsman, Robert Ellis, discovered Proxima. How did you do that?
Well,
with a telescope.
Yeah.
But do the two big stars in that trinary system ever get close enough to obliterate? Aren't they going around?
This is not to scale. This is the sun, the Earth, the edge of our solar system. This is a benchmark at 2 light years. This is 4 light years. And this is Alpha Centauri A, Alpha Centauri B, which were considered to be the nearest neighbors to the Earth. This guy, Robert Inez, was studying this pattern of stars, and he photographed them using a friend's 10-inch astrographic camera. And in 1915, and he took 2 pictures 5 years apart, and he noticed that they were all moving. Proxima Centauri, Alpha Centauri, and Beta Centauri. Alpha Centauri B, not Beta Centauri. Those are moving about the same pattern. So he figured they are in association. But whether they're gravitationally bound is still not known.
God, they'd have to be, wouldn't they?
Not necessarily.
Ron, remember, this isn't to scale.
Yeah.
I know that, but we're looking at, if you're a system, whether binary or single or trinary or whole globular, they're in the area together. Aren't they gravitationally bound?
They're almost half a light year apart.
Oh, are they really?
That's quite a distance.
But the 2 big ones don't ever get closer to us than the little baby that he discovered, Proxima?
They might if it is actually in orbit, yes.
Because the word Proxima means nearest to us, right?
Right. And right now that it's clear that the Proxima is nearer to us than Alpha and Beta. Than Alpha A and Alpha B.
And we haven't yet been able to track the orbits of these 3 yet?
We don't have enough information for one to definitively make an orbit. They're very separated. They're optically, visibly separated from Earth here, and that implies a very long orbit time.
Over centuries?
Yes.
Okay, so it may not have changed much since Robert Innes's time. Then.
Yeah.
I'll be damned.
So there's one more picture I want to show you. This is a picture of a star. It's a brightness star, because here's the magnitude of it. And this is 19.5, 18.5. So it's dim, it's out there. 17. And then this is the light pattern that was observed for it. And you see it's not a recurring, so it's not something eclipsing it that is orbiting it. It's something that causes it to all of a sudden brighten. So the eclipse doesn't dim it when something passes in front of it. It brightens it. So this is believed to be, and when the observations here, this is from the Gaia satellite, this data is. And the this one and this red dotted line is a model, and it's a model of a black hole passing in front of a star with this star's known spectral properties, and it fits it quite well. So this is claimed to be the first, possibly the first transit of a black hole in front of a star and doing a micro lens.
You're talking about a freewheeling rogue black hole,
Yeah,
not the big maybe in the center, not sagging.
Actually, there's been a fair number of those. That was the whole Ogle program.
Yeah.
For either a black hole, this may be the first black hole, but they were looking for black holes. They ended up finding transiting planets.
Right. So this is
why if a black hole pass in front, why would it get brighter?
Go ahead.
It acts like a lens.
The lensing, yeah.
It's bending space-time.
Sending us more light.
Huh.
I understand that. I just, it's scary to have those suckers flying around in the universe.
Listen, there are zillions of orphaned planets out there, some the size of Jupiter, that are just freewheeling through the space. Yeah, and you recall a few weeks ago, we talked about in the Orion Nebula finding super Jupiter's planets with no sun that they're orbiting, and in groups of two, where they're paired with other Jupiters. So free ranging, and there's a lot of crap out there. My feeling is that the shows like Star Trek, where you hit warp 5 or something, you're traveling faster than the speed of light. Trying to travel through our galaxy, it'd be like like hitting a stone wall at the speed of light. You know, there's so much out there. You're not going to find empty space.
Maybe they'll start a new series
when you're stopped. What's that?
They might start a new series instead of Star Trek. It'll be Star Wreck.
Star Wreck. Yeah.
Well, can I extend a little bit with a stupid question, Mr. President? Out there in all those black spaces between galaxies, way in deep space, could there be stars that we just can't see? Is there any?
Absolutely.
Yeah.
There are non-galactic stars out there.
Huh. Wonder what their night sky would be like.
Sometimes you can get a very well processed image of galaxies close to each other, and you can pick out a very faint white or light trail or bridge between the two galaxies that are made of stars strung out from a near collision.
Wow.
So
and there are stars in our galaxy, and I think Arcturus might be one of them, that are non-local. It's like they're passing through the plane of the Milky Way, and they came from far out, not necessarily from another galaxy, but maybe from our halo.
And any galaxy, including ours, is a collection of all kinds of little satellites, which might be some of these clusters, right? Star clusters, globular clusters, fascinating stuff.
I have a question. We got a couple minutes. Tom, what is the globular that you can see low in the horizon? I thought that was Alpha Centauri. We used to see it at the gun club and
Omega Centauri.
It's Omega Centauri.
It's a globular, yeah, Omega.
Okay, that's right. I thought when you were talking about the Alpha Centauri or Alpha Centauri A or Centauri A, Centauri B, I thought that's what we were talking about, but they were just stars. And
yeah, they're just stars.
Yeah.
Okay, so Omega Centauri.
Right. Okay. We usually see that from here in early June, somewhere there, around then.
Or is Alpha Centauri or Proxima Centauri, are they near that?
No, they're farther south.
No. Yeah, right.
Okay.
But Omega Centauri is huge.
Yes, enormous. Yeah. And if it were higher in the sky, it would outshine for us higher in the sky. It would outshine like 13, M13.
I remember being up at your house and you were looking at it with me through binoculars.
Yeah. Oh yeah. It's really bright.
It's pretty
And
pretty
it's a
big.
favorite of Jürgen. Jürgen Hilmer really likes that object
Yeah.
a lot. And he can see it from where he lives. I think he lives up 154.
Yeah.
It's hard to get.
So the word Centauri is a series of different stars. It's not just that system of Alpha and Proxima. And...
No, it's possessive of a centaur.
Oh, Tom,
It's in the galaxy. It's in the constellation Centaurus.
Right.
Okay, but
Tom,
you guys ever focus on Alpha and Proxima? Is it up there?
They're too far south to see from here.
Yeah, we can't see those, Ron.
Okay.
I had a
Omega. I was just going to mention that we could, when we used to live in the Bay Area, and I used to observe with my old club from San Jose, we used to go up into the Santa Cruz Mountains, and it was a real treat to see Omega Centauri. You could actually see it, but you have to be up in the mountains to see it there. Here you can see it. Well, we can see it in the backyard, from the backyard.
Because we're farther south.
If we got one last second, I missed a comment from Tom Totten.
Oh.
He had an acoustic wave question mark. I think this was referring to the giant red spot.
Sorry about that. You're going to have to look closer there, Tim, in the future.
Yeah, I missed it.
We've run out of time, but go ahead and answer it if you want. The heck, we can go over.
Yeah.
Well, acoustics is vibration, in the substrate there, in the gases, and so that can cause friction and heat things up.
Yeah.
And he said, what is a 3-body problem besides a Netflix series?
Not stable.
Our beloved webmaster used to be on the screen with us years ago. He could be with us instead of sitting and watching us. Asking us the question. Gentlemen, we've run out of time, but I learned a lot, and doggone, I hope I keep it. Going to be back on screen for a happy April Fool's Day 1 week from today. In 2 weeks, I guess we're going to be off. That would be the 165th program. Otherwise, number 164 is coming up, next week? And doggone, everything's reversed. And then we're not going to have the free half-hour show in the planetarium on the 12th, which is the second Friday when we meet in the Courtyard Gallery. It looks good. I don't know if I've ever been in there at the museum. Otherwise, be there by 7:30 on that night. And then Star Party will be even right before our morning of the eclipse. That'll be Saturday the 6th coming up, right? And that is after our next meeting. So we'll meet again next Monday morning, the 1st, everybody. April 8th. Happy April, and thank you, and appreciate
nice one, Gary.